Hello there, welcome to the Learning of Engineering tutorial video lectures. In this video lectures, today we are trying to find the power transmitted by a shaft. These are the series of lectures which we are preparing on the torsional shafts. So in this case, as we know, the shaft is transmitting the power from one unit to the another unit. And in this case, when it is subjected to the torque, then automatically the shear forces are going to be developing, so that we have derived. And similarly, the torque transmitted, how much amount of the torque the shaft can transmit for the solid and the hollow shafts we have seen. And today we will see the power, how much it is going to be transmitted. As we know, the power P is equal to, the indicated letter is the P, that is equal to the 2 pi n T by 60 we are going to be considering. So this is the derived equation I am going to be taking here directly, that's P is equal to 2 pi n T by 60. As we know, in this case, and the same equation, we are going to be writing this equation in this terms, omega into n, omega into T I am going to be considering. Omega is nothing but, this is going to be your angular velocity and the T is going to be the torque we are going to be getting. So then how to find out? Suppose there is going to be a solid shafts are there. Solid shaft can transmit the power, and similarly there is a hollow shaft also there. Hollow shaft is going there. So in this case what will happen? So what is the T value? Already we derived the amount of the torque transmitted by the solid shaft. The T is equal to, I am going to be taking pi by 16, the tau into d cube I am going to be considering. Because here the shaft is going to be the solid one, right? And it is going to be, the length is going to be like this, right? So the shaft is going to be existed. And similarly, there is a hollow shaft is there. So in this hollow shaft, what will happen? The shaft is going to be prepared with the hollow inside one. That material is going to be existed between the inner radius as well as the outer radius, or inner diameter to the outer diameter. So in this case what will happen? The power transmission also going to be equal to the solid shaft. So what we are going to be, to reduce the weight of the system, then we are taking the hollow shafts here. So then in this hollow shaft, so then what is the power transmitted? How much the torque it has transmitted means, that's the T is equal to pi by 16, and this is going to be the tau. That means the shear stress is transmitted from the outermost surface. So then that is equal to outer diameter to the power of 4 minus inner diameter to the power of 4 by the outer diameter I am going to be considering. By using these two equations, I am going to be finding the power in a solid shaft and how much amount of the power transmitted by a hollow shaft I can determine. So I hope you are able to understand the difference between the power transmission in a solid shaft as well as the hollow shaft. Thank you.